students. I hope all of you are doing well. Acceleration is one of the most important ideas in physics, yet, it's also one of the most misunderstood. Most people think acceleration simply means speeding up, but in physics, acceleration has a much broader meaning. It describes any change in velocity, and velocity includes both speed and direction. So, acceleration is happening whenever your velocity changes in any way. You speed up, acceleration. You slow down, acceleration. You turn left or right, still acceleration, even if your speed stays constant. This is the key idea. Acceleration is the rate at which velocity changes. Velocity already combines two things: how fast you move and in which direction. So, if either of those changes, acceleration appears. Imagine you are in a car going 40 km per hour around a curve. Your speed stays constant, but your direction changes. And because your direction changes, your velocity changes. That means the car is accelerating, which is why you feel pushed sideways during the turn. Your body is responding to acceleration. The formula for acceleration is simple. Acceleration equals to change in velocity divided by time. And the unit we use is meters per second squared. That unit tells us how much your speed changes every second. Let's take an easy example. A car speeds up from 0 to 20 meters per second in 5 seconds. The change in velocity is 20 meters per second. The time is 5 seconds. So the acceleration is 20 divided by 5, which is 4 meters per second squared. This means the car gains 4 meters per second of speed every second. Now let's look at slowing down, something students can often ask about. Is deceleration a separate concept? Not really. In physics, slowing down is just a negative acceleration. Acceleration in the opposite direction of motion. If a bicycle reduces its speed from 15 meters per second to 5 meters per second in 2 seconds, the acceleration is 5 minus 15, which is minus 10, divided by 2. And the result is negative 5 meters per second squared. The negative sign simply means the acceleration is acting opposite to the direction of motion. Now let's look at something even more surprising. You can have acceleration without changing your speed at all. Imagine running around a circular track at a constant speed. Even if your speed stays the same, your direction is constantly changing. And because direction is part of velocity, your velocity is changing every moment. That means you are accelerating the entire time. So, how does acceleration connect to forces? One of the most important ideas in all of physics is Newton's second law. Force equals to mass times acceleration. This equation tells us that acceleration doesn't just happen randomly. It requires a force. If an object is speeding up, a force is pushing it forward. If it's slowing down, a force is pulling it backward. If it's turning, a force is acting sideways. If no force acts on an object, its acceleration becomes zero and it moves at constant velocity. Everything you see in the physical world, a ball being thrown, a car braking, a rocket launching, or even a satellite orbiting, can be understood by analyzing acceleration and the forces causing it. Let's finish with a simple but powerful example: dropping a ball. When you let go of a ball, gravity produces a constant downward acceleration of about 9.8 meters per second square. This means after 1 second, its speed is about 9.8 meters per second. After 2 seconds, about 19.6 meters per second. And after 3 seconds, about 29.4 meters per second. Even though the ball starts at rest, its velocity changes by the same amount every second. That's constant acceleration. And if you throw the ball upward, gravity still accelerates it downward, slowing it down until it reaches the top, then speeding it back up on the way down. All of this Rising, stopping, falling is acceleration in action. So, to summarize in one sentence, acceleration is the rate at which velocity changes, whether through speeding up, slowing down, or changing direction. And it lies at the heart of motion in physics. If you learned something from this video, please give it a like and subscribe to the channel for more. See you in the next class.